Welcome to those of us. If you've just joined, feel free to introduce yourself in the chat. We'd love to see where you are and what your role is. And then we also, if you want to type one word that describes how you feel about what you're learning so far. I'd love to see what everybody's thoughts are on their learning journey. All right. Hi, everybody. Thanks so much for joining us. Trying to give a little bit of time for others as well. So everybody has been either introducing themselves in the chat or typing one word that describes how they feel about what they're learning so far. So thanks, Kate, for introducing yourself. I'm glad that it's been a good refresher on the design populations. Wandili, welcome. It's been very insightful. That's good to hear. Well, that's great. Feel free to keep introducing yourself, and if you think of a word that kind of describes how you feel about what you're learning so far, I'd love to see that. You can feel free to place that in our chat at any time. We will go ahead and get started. So good morning, good evening, depending on where you are. Um, so just a few reminders for these office hours. I'm so glad that all of you were able to join us today. If you are not able to join one week or you have to hop out early, the sessions will be recorded and posted. So, for example, if you missed last week's session, that is on the course page. You can find it with Unit 1, and then this session will be posted in the Unit 2 section. Um, if you're able, you are welcome to put your camera on if your bandwidth allows. And then, yeah, we'd love for everybody to contribute throughout the session. It's really a session made for open discussion and hopefully to be able to answer any questions that you might have and just to discuss what we are learning in the course right now. So a quick look at where we all are in the course. So right now, this week, we are on Unit 2. So we've been looking at steps 2 and 3 of the design process. So looking at the water source, and then the flow rate and the total dynamic head. So we're right at the end of week 2. And next week, we'll move into week 3 and Unit 3. So just a reminder that this is the recommended schedule. This is how we like to go through the course. You do have full access to all of the course material for the full 5 weeks, though. So if you get a little bit behind, you won't lose access to anything that's earlier. But we do encourage you to keep with this schedule. One, so that you can participate kind of in the discussions with everybody, all your classmates, as they're going through those. And also so you don't get too overwhelmed at the end trying to finish everything. So please stick with the schedule as much as you can. but you do have some ability to move around and to shift depending on your workloads. I know that everybody's balancing a lot of other commitments as well. Okay, so I just want to do a quick check on maybe where people are, how they're feeling about the course so far. So if you can use your reaction buttons to send up either one or more, if more apply to you, kind of either where you are in the course or how you're feeling about the Unit 2 material. We've got some votes for we really like the water source abstraction. That we've gotten through most of Unit 2. That's good to hear. Okay. Some of us are still working through Unit 1. That's okay. You have time to catch up. Some parts were confusing. Yes, that's very true. Got some confidence. Okay, so we've got a little bit of everything on the screen. That's wonderful. Good votes for water source abstraction. Okay. All right. Well, thanks everyone. That's helpful for me and hopefully helpful for everyone to see kind of where others are, but it's helpful for me especially to know kind of where we are and hopefully some of the questions that are going to come up in the call that we can get through today. So we did most of our Unit 1 review last week. So if you missed that call, you can go watch the recording if you want to see that. I did want to give a few minutes this morning in case there were any other questions that you might have about Unit 1. We'll have some time to talk about those. And I did, now that we're mostly through Unit 1, want to give time to talk a little bit about the discussions because I thought that might be insightful for everyone to get to see kind of some of those main themes. So I'm going to put this up real quick. This is a word cloud based on all of your responses to the Unit 1 discussion. So again, I just thought that would be interesting for us all to look at for a moment, kind of see the major themes. So of course, water demand being the biggest theme, because that's what we're talking about in Unit 1. But as far as what everybody had to say in their what actions they would take and the implications of those actions. These are the major themes. So sustainability, everybody's very big on sustainability, community water use, stakeholder engagement. I love to see that one so big. If you're coming from the 101 course, we talk a lot about stakeholder engagement, and it's true in the design process as well. So it's very encouraging for me to see that that's been such a major theme. Um, Talking a lot about standards, and then like in the practical side, household surveys, data triangulation. So these are great ideas, right, for how we sort through the conflicting data over water demand and really any conflicting data that we have through the design process. So if anybody has any kind of questions or thoughts related to maybe what you're seeing for the discussion posts or for water demand, I've got a couple maybe to kind of prompt your thoughts. Um, but feel free to type in the chat or to unmute. It's a small group today, so feel free to unmute and speak. But kind of what issues have you had calculating water demand? Or just any other thoughts you might have on that discussion post. Yes, Kate, I see your hand up. You're welcome.
Yeah, I was just trying to say how it can be really interesting when you're engaging communities and they feel that, they're going to have a very high water demand because the need for water is so strong in their community and whatnot. But then And then you can also do like a willingness to pay survey where everyone commits to being willing to pay for the water to help sustain the system and everything. And then sometimes you get to the reality and people really are only buying 3, 4, 6 liters a day. And it's because then people will use competing sources for non-potable use instead, or, due to their financial situations, they just choose to not prioritize the purchase of water and using surface water and whatnot. So it can be really interesting, like when you first engage community, yes, they want all this water. Yes, they're going to use this much. Yes, they're willing to pay. But then sometimes the reality is very different.
Yeah, I think I've seen that in my experience as well, where we might plan a system and we might plan it to be fairly large based on what we think is going to happen. And then in reality, you're right. Maybe it's less. Um, I'm wondering if anybody else has had experience with that as well, and maybe what you did. In that case, I think the biggest issue I've seen in those particular cases is the financial sustainability of the project after, because you might plan for it to take in a certain amount of revenue to replace pumps that might be larger than they actually needed to be. Yes, Ahmed, would you like to share?
Uh, no, not really sharing, but I kind of had a question
Okay.
regarding, yes, yes, if it's okay. Um,
Yes.
Maybe the other colleagues could help. Yeah, so um, it looks to me like you calculate maximum water demand, you also calculate, future use. That's when you add population growth, but then the the value that is chosen is the planned design, which just takes the population demand and including system losses. So is it because of the availability that the population growth is not the value with the population growth is not considered, since that is much higher than that planned design? Because I would think that would be safer to use. That's just my question, if you get what I'm saying. Yeah.
Yes, I think so. And you can always ask a follow-up question if I don't fully answer. It's a really good question. Yes, in the examples in the course, we do talk about how to calculate population growth, but then in the actual design, we don't use that forecasted growth, do we? Um, and there might be a couple of reasons that we do that in reality. At least in my experience, it's typically maybe a funding limitation. It would be really great if we could plan all of our systems for the future population and have room built in to grow, but maybe there's a budget limitation that doesn't allow that, or maybe we know that we're going to put this system in now and then maybe make improvements later to increase the capacity rather than doing it all at one time. And again, like we just mentioned with Kate, that can also have um, impacts on the financial sustainability, right? So we might put in a very large system based on a future population, but maybe the current population can't keep up with the operation costs or the maintenance costs, even the replacement costs. So yes, so for planning purposes, you're right. It's usually safest and most conservative to be able to design based on that future population. But in reality, I think what I've seen a lot of the times is maybe we're not designing for that full future population because of some kind of restraint. I'd love it if does anybody else have experience with that, or maybe have you done your designs with future population, and how has that gone in your projects? Yes, Sarah,
Good afternoon, everyone.
welcome.
I'm a bit struggling with the connection because I am on site.
Mm.
Ahmed, his question is valid. for this case, because it was my question as well. But the justification was given from Jessica and from the module as well, that this is the first phase of a potentially large project. So they considered the maximum demand at system commissioning to compute the individual demand. But in most cases, as far as I know, maybe other colleagues can confirm this, water supply projects usually designed for a large number of years, like 25 years and 20 to 25 years, and sometimes more. So during these years, there will be a population growth. So the projects needs to be designed for an anticipated future demand in most of the cases. If you see in our case, the calculated anticipated future demand is a very big one, around 30.8 liters per day, which is bigger than the maximum demand at system commissioning and the anticipated demand at system commissioning. This is because it considered the population forecasting. The population is forecasted for the coming 25 years. So this is a special case, but for most cases, we use the anticipated future demand. Yeah.
Yeah, thanks, Erhan. Those are good points. Yes, in most cases, we do go towards that anticipated demand just to be able to use the averages and kind of balance those water use numbers that we are seeing. Harish, I see your hand up as well.
Yeah. Good morning, ma'am.
Welcome.
I am from India. I am working in the water sector since 54 years. And working in solar water pumping solution for about 15 years. And I have designed approximately more than 2,000 standalone solar pumping systems. So my first question is, we are going for the calculation of water demand in both the locations where we have considered the borehole, right? Under the condition, because we are taking the groundwater as a source, yield may be limited at some places, right? And again, to my Indian experiences, I am talking here, Jessica. Basically, with the time and space, I have put at this point in discussion forum also, if with the time and space, rate of groundwater depletion also takes place. Secondly, it is governed by the aquifer conditions or extraction condition nearby areas and geological. So mostly the water document, I have gone through UNICEF document, which has been suggested for reading. It does not mention how to ensure the design yield. I am putting up a design yield. Here we are talking about calculation of the yield when you are this is a long-term pump test, right? Constant flow rate pumping. But if I am taking that yield in where it is a non-summer yield, how to adopt the design yield, I think we should come out with some specific guidelines. And secondly, again in the demand, if we create an example, say, whatever case may be, I'm not talking with a country specific. So WHO recommends example, I'm giving example 20 LPG of domestic use, right? So here guideline again suggests that institutional need, I have to define that basic institution, right? So I will be happy that if you can put in way that this one, say a school, yes, you have taken the school, but how much quantity a school is coming? Because a school is only for 2 or 3 hours, right? So the consumption will be limited for the drinking and hygiene purpose, right? Secondly, then other institutions. So I will be happy that if you can put in such a way that how much percentage of domestic use can be used for the institution. for easy calculation, right? Again, for the water losses, you can keep as a, if it is a standalone system, maybe if it is a pipe system, maybe 5 to 7%, maybe a standalone, maybe a high 1 or 2% hardly, then filtration losses. So if you can define in that way, I can suggest you one document which has been developed by me for Aga Khan Foundation, especially for the African countries. And this is under the printing with Aga Khan, where I had given the details of the solar water pumping design. And for I think forwarded to the Global Water Center or WSN also. So if we can more specifically define the things, so design will be more easier, Jessica. Thank you.
Yeah, thanks, Harish. It's very cool to hear all of your experience with solar powered water systems. I'm so glad that you're in this course with us, and I'm hoping we can learn more from you. Yes, thank you. Thank you for sharing your thoughts. It sounds like there's a resource that you've been using, and yes, if you'd like to share that, that'd be really great. It would be great to have some more of these guidelines. So for like water loss, to be able to, based on the system type, have more specific guidelines. I think that will come down to just more recognition of what is typical for those projects, and it might change, as you mentioned, for different contexts as well, and same with institutions. So what we have, right, is mostly WHO guidelines, World Health Organization guidelines for schools and hospitals, and we can use those as a starting point in our designs, but we might have to change for our context, right? So we might have to change based on the country we're in, the community we're in, and just what we know about those communities. So, Yared, I see your hand up as well.
Thank you, Jessica. Just want to highlight some points, and also I do have one question regarding the anticipated demand. Our colleagues were saying that we have to consider anticipated demand for design. It's obvious, and we do that here in Ethiopia. But the question is, we have to check and balance the water we have if it's going to meet that demand, depending on the allowable abstraction aspect. And the other point I want to stress here is when we used to design system with a grid or a gen set, we usually take 1/3 of the maximum demand for reservoir, service reservoir construction. But with solar, if it's only option, we multiply by 2, even the maximum one, to have one day. And that will be also another challenge we have to encounter from the beginning. So what is the experience from others on this part? Because last year I did one solar system on existing design. For example, we had 300 meter cube reservoir, but the daily demand of that population is more than 300. Because when they did the calculation, they take 1/3 of that reservoir. So I have to use the system as it is rather than adding reservoir. I considered 50% plus on the discharge when I did the calculation for the system. That means I designed 450 meter cube per day that solar can produce for that community. Maybe they can use while the system is running, because we use daily at least 6 to 7 hours if we have automatic dosing. While we pump the water, community can also use the water using the distribution line. This is the one option I used. I don't know if it's the right one or not, but I would just want to hear other experience from other colleagues. Over to you.
Yeah, thank you. Okay, so it sounds like you're asking specifically about water storage or reservoir size. If I didn't catch that correctly, you can correct me. So in my experience for solar powered water systems, our typical guideline is half the daily demand up to 3 times the daily demand is kind of our range for how much water storage we would like to see. that can be a big range. So you do have to know the community a little bit and be familiar with maybe their actual water consumption to be able to gauge where you fall into that like half to 3 times range. But there's a couple of reasons for the lower limit as well as the upper limit. So the lower limit, as you mentioned, solar only runs a few hours a day, right? We can only run it, assuming it's our only power source. We only run it when the sun is up. But we typically need more water, especially like late in the evenings or early in the mornings. That's mostly when our community is up collecting water, and that might not line up with when the sun is up and operating. And so we need that storage to be available in those peak times after maybe the sun goes down or before it comes up. On the high end, we would really only recommend no more than 3 times, and that's a water quality issue. We don't want water sitting in tanks too long, especially if we're doing like an inline chlorination before it gets to the tank, because you might lose your chlorine residual if people aren't using the full amount. And you might have some water quality issues happening if the water in that tank is not kind of turning over every couple of days. And so again, that's just where it comes into knowing, okay, how fast are they maybe actually going to go through this water. And then finally, of course, as we've mentioned, budget can always be a constraint, right? So maybe you have to start your system off with on that lower end with maybe half the daily demand, and then we can increase maybe in a couple of years, maybe we have some funds to be able to add a second tank if we need one, and that can help kind of buffer our system. So let me know if that covered your question, or if anybody else has experience on this. We'd welcome your thoughts too. This is great. Thank you everyone for sharing your comments and also your questions. I really appreciate that. That's what we hope that these sessions can be. So again, if you've had experience or further comments on anything else we've talked about so far, you're always welcome to come in as well. As you heard, I mean, Harish has so many years of experience, and I'm sure many of you are the same. I have about 7 years of experience, and so, on the scale, I'm not the most experienced in this room. So I will try always my best to answer your questions, but others of you might have more experience in a different area than me. And so please feel free to always add to the conversation. I will also say, so we've talked a little bit this morning about when we design a system and then maybe the community doesn't use as much water as we anticipate. What I saw a lot in the question and answer forum over the past week or two is situations where maybe we choose the design demand, but then our use is actually higher because maybe we've had an influx of people. So maybe either just seasonal populations have come in, maybe there's been kind of an influx of refugees to the area that we weren't anticipating. And so that seems to be a common experience as well. And these are just challenging situations to plan for, right? So again, as much as possible, we try to know the area and what might happen, and we make our best judgments that we can. And then in some cases, maybe in a few years, we have to try to make some updates to the system because something that we couldn't anticipate has happened. And that might be what happens, right? We can't know everything that's going to happen in the future, even though we'd like to. So that's where we just have to make our best judgments sometimes. Okay, any other questions related to maybe Unit 1, water demand, any other challenges with that unit? Yes, Sarah.
Thank you, Jessica and the team. I want to raise a question on Unit 2, if it is okay.
Yes.
You gave us a schematic for the typical borehole of Kikuba, actually both sides. On the schematic, the naming, the terminology are a bit confusing for me. For example, when you do the borehole schematic, even during pump test or well development activities, we need to know where the screen casings and the blind casings are located. And the other point is that when I see it on the diagram here, given in the module, the pump is positioned, of course, a little bit lower than the dynamic water level. But the screen, the casing is really written simply as a casing, the casing where the pump is positioned. Is it blind casing or screen casing? In my knowledge, we never position submersible pumps on screen casings. We always position it in blind casing. So this needs to be clarified. The picture has no details on this one. The other one is, for example, on the same schematic, casing depth to screen is 70 meter. Casing depth to the screen is 70 meter. And below that, there is also 12 meter screen. And below that, there is a 3 meter casing depth to the bottom. So my question here is, in Ethiopia, in our experience, after we drill a borehole, we put the casing all the way down to the depth of the borehole. Maybe some other colleagues can also give their ideas on this. Then after that, we position, of course, to protect the borehole from failing. It has to be protected from top to bottom of the borehole. Then we position the pump. After we calculate the pump position, we position it in blind casing, not that of in screen casings. So I just want you to clarify this for me on the schematic. Thank you, Jessica.
Yeah, that's a great question. I will say that the schematic is probably not perfect in its illustration. So, and that might be true for all of our schematics, right? We might not have every detail in there. So if you do have confusion on that, I understand. Most of these schematics are created in simple software, so we can't be perfectly perfect in it, or maybe it doesn't. Yeah, maybe it doesn't show every detail. So sorry if that's caused confusion. The biggest thing would probably be to go based on the numbers that we've given. So where the pump is compared to where the casing is, based on like the meters that we've been given. So, and I'll admit that borehole construction is not my area of expertise. So if anyone else here, I know we have some hydrologists in the course, we have some drillers in the course. If anybody else would like to answer that and clarify as well, please feel free. Because I see another question in the chat as well, asking if it's good practice to alternate the screen versus the plain casings. I've seen that done as well. I don't think, in my experience, that is necessarily the recommended way to do it. I typically hear recommended that you would do a section of plain casing, one section of screen, and then the following with the plain casing. But again, if anybody else has experience in this area and wants to jump in, please feel free. Yared, yes.
Am I coming out clear?
Yes.
Hello?
Yes.
Yeah, maybe on the casing part, what you mentioned is we usually use blind casing at the bottom for the stability of the well. And then the screen one will be based on the logging of that well, where
Mhm.
we assume that we can get enough water. We put screen casing, and where we might face clay soil type where that will disturb the water turbidity. We put blind one, and it's also advisable to have in between even the blind one for the stability of the well. For example, in the region where we expect more water, we usually use 2 to 3 casing, screen casing, but we have to add in between blind one for the stability of that well. Because we are going to add gravel and others, and that will be a challenge in the future.
Mm.
And after saying this, I want to add one question on unit one, if it's fine from you.
Yes.
Yeah, on unit one, we did the water demand, especially for the refugee one. We followed the standard 20 liter per second per individual per day. But for the community, we use the daily demand based on the assessment of the site. In our context, we have standards in Ethiopia where in rural areas we usually consider 20 liter per second per day for individual. In suburban and in cities, there might be class of cities where it's 40 liter per second, 60 liter per second. And is it obvious to deviate from those standards, or what's the right procedure? Because as you said, it's good to know in detail and do some research at site level to know the daily use of the community, but that's not the procedure we are following most of the time. It's time bounded, and it's the resource limit is there, and people usually use the standards there to come up with some calculation rather than going to household level and ask them when they are going to get water or not. Just want to hear other experience on this part. Over to you.
Yeah, thanks, Jared, both for your comment on the borehole construction. Zerahun, I will follow up with you on possibly an updated diagram to show those details. And then, Jared, with your question, that's really interesting to hear that Ethiopia has their standards set. That's really great. Not every country does. But yes, you're right. It can be a little bit of a challenge if we know that maybe the standards are higher than what a community might actually want or need or will be willing to pay for. And in my experience, it's that kind of willing to pay for aspect that um, can lower our demand, maybe closer to that 6 that we're seeing in the course. It's a challenging situation. Um, because the first side is if you have local regulations and you have to stick with those because they're nationally mandated or you need to get approval from a water board or a ministry of water. And then you're kind of tied in to those standards, right? But there have been cases I've seen, particularly I did some work with our team in Uganda, and they're similar. They have similar standards set, but they knew that the particular community wasn't going to be able to pay for that much water. So for the 20 liters, and they knew that the community just wasn't going to use it, and that was going to have some financial implications, right, on the system. They weren't going to be able to pay to operate or to maintain this larger system. And I believe what they did in that situation is they did a willingness to pay survey essentially in the community and kind of was asking the community financial questions about what they'd be able to cover as far as a water fee. And they were able to use that to kind of justify a lower demand. Um, Especially you can do that if you're looking at maybe alternative water sources. I know that's been brought up as well. Not everybody maybe is going to use the water system we put in as much as we'd like them to use the safe drinking water option. There might be other water sources that they use in different seasons, different times, or for different purposes. Um, so yeah, that's a challenging situation. I hope that helps a little bit. I don't know if others or have a similar challenge in their areas. You'd be welcome to share your experience. Yes, Zerhun, I see your hand up.
Okay, Jessica, thank you. I'm coming again and again. Thank you very much, Yared, for the for your insights on the borehole schematic. Yeah, my question was, is this schematic given by the Global Water Center? Like, is it realistic? That was for me. It was no. I found it non-realistic. It lacks details. So my question was to confirm this one, and Jessica confirmed that it is like brought by some kind of software. It's a general one, and also Yared explains the details, like Yared said. There should be a geological investigation when you drill a borehole, and the geological investigation will reveal the borehole schematic, the casing arrangement, and the type of formations, underground formations, and even the casings will be arranged based on the underground formation, like Yared said. For example, if we need to get more water, we put the screen casing, for example, on sandy formations, so that if it is sandy or a more porous formation, water can easily flow into the casing, so that we put in that specific location a screen casings. If we assume that if the formation shows that if there is no porous media or like clay or some other kind of formation, we put blind casings. In such a way, the casing arrangement will be done during installation. This is totally clear for me. So I take the schematic given by the Global Water Center as a general one, and not yet. Okay, thank you very much. Before I finish this one, I have also one question for you. During the constant rate pump test, of course, we have here most of the time do a constant rate pump test. In our case, we do it at least for 72 hours. I've done many boreholes, but in this case, it is done for 12 hours. Depending on your budget, depending on other factors, you may reduce the hours. But as long as you increase the hours, your result will be realistic. The chance of your result to become realistic will increase. If you do it for 72 hours, you will get like realistic yield of the borehole, so that when you install the system and when you operate the system, you will not face a problem in the future of water shortage. But 72 hours is still not enough, because we will use the system for 25, 20 years. So still it is not enough, but it is better. Relatively, it is better to increase the pump testing hours. Coming to my question, we chose 4 m³ per hour and 72 m³ per hour as a minimum and maximum for target flow rates to start the iteration of the pump test. Because in order to start the iteration, we need to have the minimum and maximum flow rates, target flow rates. And you said that these values are taken from the surrounding wells. Okay, if you take it from your surrounding wells, how did you take it? From what type of document is these values taken? These are my questions. And if there is no other well to refer in the surrounding area, what would you do? So these are my questions. Thank you very much, Jessica.
Yeah, thanks. Those are good comments. You're right that A longer pump test, like 24-hour or even 72-hour, if you can do it, is a great option because it's going to give you a more realistic look at what your long-term abstraction can be safely. There have been situations, though, depending on how remote the well might be and what the safety considerations are around there, where doing maybe an overnight pump test just doesn't feel like a good option, or maybe, like you said, the budget just isn't there to staff it for that long. So yes, in some cases we do need to do a shorter one. And in those cases, it's usually good to be a little bit more conservative on what we do with the results. So if we get an abstraction rate in like an 8 or 12 hour pump test, maybe we don't want to plan our design flow rate to be too close to what that abstraction rate is, if possible. Maybe we could take it to be a little bit less. Hopefully, there's a little bit more margin there just to account for the fact that we had a shorter pump test and maybe we didn't get to see everything about the well and how it will hold up long term. Okay, and then for your second question, yes. So I believe you're talking specifically about the yield test procedure that is in the written guide. And so just for everybody, there is a procedure in the written design and installation guide for a 24-hour yield test. And so we don't go specifically through that in the course. In the course, we take the data that kind of is output from a yield test and we learn what to do with it. But in the guide, we do walk through a procedure that you could use to do one of these pump tests if you needed to. And as Zerhoon mentioned, it's a step test. So essentially you start off at a lower flow rate. So like he mentioned, maybe 4 meters cube per hour. And then every few hours you increase your pumping rate, increase your pumping rate, increase your pumping rate, right? Until you find what that maximum might be. Basically is where your water level is stagnant, right? Where your water level stops going up or down as much when you hit that rate. And so the challenging part, right, is determining, okay, what are those steps going to be? You have to have an idea of what you think the borehole is going to be able to produce before you go into that step test or that pump test. Mainly because you need a pump that can hopefully work, right? You don't want to use a pump for your pump test that's going to pump way too much water or not enough water because you want to find that true maximum and you don't want to over pump right off the start, right? So you have to be able to estimate what the pump is going to be. So you have to be able to estimate what your borehole can do before you've done a pump test. That's the challenge, right? So yes, there's a couple ways we could do that. In experience, one of the nice ways to do it is hopefully you have other boreholes in the area that might be within the same aquifer, and maybe those have had pump tests done on them, or at least maybe drilling records that have estimated the yield. Well, that's not as accurate as a true pump test. It can give us a starting point, right? Again, just to be able to estimate the pump that we need for that pump test. So those would be my two recommendations, either a drilling record that estimates the potential abstraction or records from nearby wells. So maybe they have either a system in place that they know what they've been pumping consistently, or they've done a pump test or have drilling records that show estimates as well. And we just kind of have to take the best data that we can find, right, to be able to estimate that. And hopefully that, get the pump that we need for that pump test. Yared, yes.
Thank you, Jessica. I just do have one question for Zariu. Yeah, he highlighted that we have to do 72 hours pump test, and there are occasions when we do only for 24 hours because we usually pump water on daily basis to the maximum of 8 to 10 hours. When it's solar, it's obvious it's 6 or 7. But even for grid system, we use 8 hours. Do we have any recommendation range where we need to do 24 hour, where we need to do 48 hour, where we need to do 72 hours? Over to you.
Okay. let me clarify. So it sounds, are you asking for recommendations on when we would do 24 or 48 or 72?
Yes, yes.
Okay. Yep. So in my experience, when we can, it's best to do a longer pump test. So like Zirahun was saying, we get a more realistic picture of what the well is going to be able to do long term if we could pump for 24, 48, or even 72 hours. So we might say that that's best practice. So that's the ideal. You might be able to pump a well for 6 hours and get an abstraction rate, but sometimes it doesn't mean that the well can withstand that, for 24 or 48. And so that's what we hopefully need to look at when we're doing the longer pumping tests. So, but as you mentioned, it can be tricky with budget, safety, just logistics. It could be challenging. So I'd say anytime that you can do that longer test, I would. But if you can't, do it for at least as long as you think your system will run each day. And then again, hopefully be a little bit more conservative, put a little bit more margin, hopefully, between what your flow rate is going to be and what you got for your maximum abstraction to try to protect that water source. And it might be that maybe larger projects that are going to really use a lot of water, maybe like if you have to be very picky about when you do your long pump tests, maybe you save them for like the really large projects that are going to have you're going to have a very large flow rate. Those would really be situations to do that longer test, to make sure that it's going to be able to handle that large volume of water. You want to make sure that it can sustain that long term. But yeah, even for smaller projects, it would be best to do that. Zirahun, I see your hand up.
Okay, thank you, Jessica. To add on you for Yared, like Jessica said, there is no fixed standard to do for this borehole. You do 24 hours for this type of borehole. You do, but in experience, in my experience, if the borehole is if it is a deep borehole, to be drilled for very big like urban water supply projects, it is always recommended because we expect a bigger yield and also the population to be covered or benefited will be very big, so that to get a realistic value, it is always recommended to increase the number of pumping hours. Like 3 days or 72 hours is most of the time it's recommended. But otherwise, if it is a shallow well or if it is like a medium or small scale project, if you have budget, better to do a 72-hour test. Otherwise, 24-hour test, or worst case scenario, 12 hours pumping test is recommended. This is my from my experience and my reference. But Jessica, you didn't answer my second question. Maybe you answered it, but I don't understand it. I don't know. The question is, two numbers are. I am trying to review all the book because to get more knowledge. That's why I also reviewed the Appendix C, which is all about this pump test, all the procedures. These two amounts, maybe you will discuss it next time. The 4 meter cube per hour and 7 meter cube per hour target flow rates to start the pumping test are taken from another surrounding boreholes. Okay, if they are taken from another boreholes, there should be a pumping test report. From that pumping test report, what are these values? For example, 7, is it the maximum yield from that document? What is 4? Is it the starting discharge taken to conduct the pump test in that document, I'm confused. You know, these two numbers are put here. But technically speaking, I would say 7 meter cube per hour. Maybe it is the maximum yield of that the borolene we are referring, and 4 meter cube per hour. Maybe it will be the starting target flow rate when they conduct the pump test during that time. This is likely. These are this will be the scenarios in my case. And thank you very much for your time and for the chance given me.
Yeah, no, thank you for clarifying that question. So let's see. So what we're really trying to do when we determine what the steps are or what our starting point is trying to plan for a range that might cover what a nearby borehole can do. Because we want to give room for maybe the borehole we are testing to be a little higher or a little lower than one that might be nearby that we have data for. So maybe the one that's nearby, maybe we know that, for example, it could do 6 meters cubed per hour, and that's its maximum. And so maybe we decide to start at 4 with the hope that we can go up and maybe have a little bit of room to go above that 6. Maybe our borehole can do a little less or a little more, but maybe it doesn't do quite as much, so we start lower. So I don't think there's a very specific, here's exactly what you do, but that's in general what we're trying to do, is to catch that, what we know a nearby borehole can do, catch that in our range. Because we're assuming our borehole might be similar, but differ a little. Hopefully I did a better job that time of answering your question. I do see one question in the chat. I want to make sure. Okay, good. So you're saying you're having trouble calculating the 80% allowable extraction. So yes, when we do a pumping test, there's different terms, right? So there's abstraction. Some people use maximum yield rather than maximum abstraction. I'm more familiar with yield, but yes, so in the course we're using the term abstraction. So when we do a pump test and maybe we get a maximum abstraction rate, some locations, some areas might limit what you can do. So in some cases, you might be limited to 80% of that abstraction rate. And so what we're doing in that calculation is basically taking what we have gotten for our abstraction rate times our limit. So in the course, specifically for Cucuba, I think it's 3.5 meters cubed per hour. So we're multiplying that by 80%. And I believe that comes out to be 2.8 meters cubed per hour. So really it's just the 0.8 times our abstraction rate. So if you have further questions on that, please let me know. You can put them in the chat or speak up. We are coming to the end of our time today, but yes, if there's any more questions, feel free to put them in the chat and I will make sure that we get answers to you. I really enjoyed the conversation today. We didn't even get into our Unit 2 review polls, which is perfect. Those polls are only here to kind of spark some of this discussion. And so I really appreciate that everybody came with some questions today and some comments to share on the unit. So next week, maybe we'll go through some of these Unit 2 questions as just a wrap up on Unit 2. Let's see. I'm going to click through. We'll do some of this next week. It will be hopefully fun. Any challenges with the design tool for steps 2 and 3? And I understand we're at the end of time, so if you need to hop off, please go ahead. But have there been any challenges I want to check on steps 2 or 3 of the design tool? Hopefully everyone's been able to download that and start using it. If you have challenges when you're completing the design tool, feel free. The WhatsApp community has been a great place for questions. or you could put them on the questions and answers forum if you prefer not to use WhatsApp, and we'll make sure we get those answered for you. And then just to look ahead at next week. So next week, we're going to start Unit 3, and that's going to be all about pump selection. So looking at our flow rate, our TDH, and how we select a proper pump, and specifically what we need to look at to select a pump that will be good for a solar system, because there will be some particular things we need to look for that. So yeah, thank you again, everybody, for coming and coming with the great discussion. I really appreciate that. Next week's call, we will go through a little bit more Unit 2 review, just to cover that. And then we'll start on some Unit 3 review. So yeah, thanks everyone. Again, if you have questions between now and then, the WhatsApp community or the question and answer forum is a great place for those questions. And I hope you all have a great weekend.
Thank you. Same to you and all.
Thanks, everyone.
Bye, everyone. Bye.
Bye.